How to evaluate the impact of wind load on building projects. Welcome to Building Knowledge 101. In this video, we cover the critical method of evaluating the impact of wind load on a building project and the importance of understanding how this is driven by a project's location. So to start in evaluating what the wind load is for your project, here's a website, ATC. This is a great place to start. When you bring the website up, it's going to ask you to enter an address here. So when I enter an address, put one in that's in Virginia Beach, comes up on the map here and it shows you exactly where your address is. So now we've located the location of our project. Now we need to assign it a risk category. So you can see over on the left side, I have the optional risk categories. So I'm going to pick risk category 3. So here we have risk category 3. You can see it's brought up our wind line here. So here you can see the 130 mile an hour wind. So we are more than a mile from the coast, and we're not quite at the 130 mile an hour wind. So we are non-impact at this point. So if this project being risk category 3, based on the location, is non-impact. But if I were to change this to risk category 4, now you can see the 130 mile an hour wind line has moved inland of us. So we're now at 134. So we have to now be impact. Here you can see the 140 out here. So you can see how the wind lines have moved based on what the risk category is. So by changing that from risk category 3 to risk category 4, at the same location, we went from non-impact to impact. So let me give you another example. Now we're going to look down at the coast of Georgia. This is down along the coast of Georgia in Brunswick, and I've entered my address, and the map, ATC, has brought up and shown my location on a map. Now it's going to ask me, what is my risk category? So at this point, I'm going to go ahead and choose risk category 2. And we can see our 130 mile an hour wind line is here. We're a mile inward, and we're below the 130. We're at 129 miles an hour wind speed. So we right now at this point, we are non-impact. But if I change my risk category and bump it up to 3, you can see now the 140 mile an hour wind band has moved inland. So when we looked at those wind load charts earlier, and I was pointing out where the 140 mile an hour wind line was, you can see as we increase the risk category, move up from a 2 to 3 to 4, we're changing where the wind line is. So we're moving the 140 in. So as projects increase in their importance, we're bringing the wind loads higher to build the standards up for them. So this is risk category 3. If I take it now to risk category 4, look, here's the 150 mile an hour wind line. It's come inland, and I'm now having to evaluate this project based on 149 mile an hour wind. So again, getting the wind load correct based on the importance factor is critical for every project. So now we're back to ASCE 7. And you can see we talked about these variables, your wind speed, building exposure, importance factor. And now it's going to generate, based on this information that we've entered, it's going to generate our components and cladding chart. So here's an example of the components and cladding chart. And you can see we've got roof zones here and then wall zones here. So ASCE 7 breaks every project down, every building down into zones. And then also notice that here is calling out positive wind zones and negative wind zones, because we've determined as wind hits a building, it's going to be positive on one side and then negative on the back side. So ASCE 7 really breaks down your wind speeds into wind loads, giving you a lot of good information based on the zone, because as wind hits a building, the pressure of the wind varies based on where on the building is hitting it. So we have zones that we're looking at. So here's a complete components and cladding chart generated from ASCE 7. Then I want you to notice that there are 2 levels of wind load calculated. First one is the load resistance factor, or the LRFD. Again, this is the ultimate wind load. That chart is called out here. This is again based on high wind probability in a 500-year cycle. And then right here adjacent to it, this is the allowable stress design. And again, this is more commonly used. This is based on a high wind probability in a 50-year cycle. So again, this is probably more commonly used, but you do need to make sure when you're evaluating a project which components and cladding chart you're required to use, whether it's the load resistance factor or the allowable stress design. And again, looking at this, you can see The charts here are broken down into zones. You can see here we have positive zone 4 and 5, negative zone 4, and negative zone 5, and then corresponding pressures with it from 16 here to negative 20 on the backside at zone 5. So you can see wind pressure across a building is not consistent. So every zone has to be evaluated and making sure that the product we're choosing is going to hold up to the zone that it's being used on. Now, moving back to kind of the middle of the United States where more tornado-prone areas are, we think of high-velocity wind zones as the coastal area, but it's also here in the center of the United States. You can see on this wind zone map, the kind of the eastern side of the middle of the United States, we have wind speeds that exceed 200 miles an hour. The coast is what we're thinking about as prone for hurricanes, but this dark area here in this wind load map is where we're prone toward tornadoes, and we're all very familiar with the amount of damage that can be done by tornadoes. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.